Today's topic is power. Wind turbines create power. So what is power? Power is measured in something called watts. You open up the screen. So watts are equal to your volts times your amps. Watts are always measured in power per hour. So a 100 watt light bulb uses 100 watts per hour. That's the amount of power it uses in an hour. I looked at the back of a couple of things. So like for my computer, the one I'm using right now, on the back of it, it's got 19 volts and 2 amps listed on its little sticker. It's got V for volts and A for amps. And so if we wanted to calculate the watts, it's volts times amps. So the watts of my computer are 19 times 2, which is 19 times 2 is 38. So my computer uses 38 watts per hour. This equation is kind of helpful if we want to figure out other things. A 13 watt light bulb only has listed 120 volts. It doesn't have listed the amps. So for the equation, we have 13 watts equals 120 A for amps. So it's 120 times amps, 120 volts times amps. So because it's times, in order to cancel out the 120, we need to divide. So it's 120 divided by 120, which cancels it out. And it's 120 divided, it's 13 divided by 120. And then on a calculator, 13 divided by 20 is 0.1, so 0.1 amps. Light bulbs use 0.1 amps, 120 volts, and they're 13 watts. That's an energy efficient light bulb. I also have an electric heater. It's 1100 watts, and then it has 10 amps. I don't know the volts. So it's 1100 watts equals the volts times the 10 amps. So again, because it's volts times 10, we have to go backwards and divide. And divide by 10 cancels out. And then 1100 divided by 10, you get rid of a 0, and it's 110 volts. So my heater uses 1100 watts, 110 volts, and 10 amps. Now, what does that mean? What is an amp? What is a volt? Amps are your carriers. They're kind of like your buckets. A small amount of amps, let's say 10 amps, is like a small cup. And when you have electricity, electricity is always electrons. I'm going to use beads as electrons. So amps are your carriers. They carry electrons. So a small cup can hold a certain number of electrons, like this. That's 10 amps. 100 amps would be a much larger bucket. And 100 amps can hold a lot more electrons. It can hold thousands of electrons. So we've got 100 amps, 10 amps. Small cup, bucket. Volts are your push. Volts are how quickly I can empty the bucket. I can take this bucket, take this cup, and I can empty it really slowly. That's like 100 volts. Or I can empty it really fast. That's like 1,000 volts or more. I can do the exact same thing with the big bucket. I can empty it really slowly or really fast. Really slowly is a small amount of volts. Really fast is a larger amount of volts. So carrier or buckets is amps, speed is volts. If you're thinking about it in terms of water, which is a very common way to think about it, a small stream, like the stream coming down Killington Mountain, or any small stream that you can step over, has a small amount of amps. That exact same stream, like in the middle of the summer, is going to be moving very slowly. It's going to have a small amount of volts. When it rains, a large amount of volts. A big river, one that you have to swim across, has a large amount of amps because it's larger in size. Same thing. In the middle of summer, it's moving slow. You might be able to just walk across it. It's got a small amount of volts. When it rains or the snow melts and all the water is gushing down it, everything's moving a lot faster and it's got a high amount of volts. So in the examples of streams, you can easily change the volts by just adding more water, but you can't change the amps. In electrical power systems, amps are like your wire size. They can be small or they can be large, and you can't really change it. And then volts is how much electricity you push in. You can put in a little, or you can put in a lot. Hopefully that makes sense.